The map of our world is about to change. And I'm not talking about China breaching boundaries. I'm talking about the continent of Africa splitting into two.
Ever wondered how continents move? In East Africa, a massive crack hints at a future transformation. Tectonic plates are slowly pulling the continent apart, creating the Great Rift Valley. This video dives into the science behind this fascinating geological phenomenon, exploring its impact on landscapes, ecosystems, and even human history.
A massive crack in the ground that's estimated to be up to 50 feet deep has opened up in Kenya seemingly overnight.
Africa is undergoing a dramatic change, a continental rift. This means the continent is slowly splitting into two pieces. The culprit, tectonic plates. Imagine Earth as a giant puzzle that keeps rearranging itself. Millions of years ago, all the continents were fused in one supercontinent called Pangaea. Over time, Pangaea cracked due to movements in Earth's crust, which is made up of giant slabs called tectonic plates. These plates are constantly shifting, sometimes pulling apart. That's exactly what's happening in East Africa. The hot core of Earth heats the plates, causing them to move. In East Africa, two plates, the Somali plate and the Nubian plate, are slowly separating at a rate of a few millimeters per year. This movement stretches the land, creating cracks and valleys, the Rift Valley. This continental breakup isn't happening overnight. It's a very slow process that started millions of years ago, but the effects are visible. In 2005, a large crack appeared in Ethiopia, splitting a house in two. The long-term implications are mind-boggling. Over millions of years, this Rift Valley could widen into a massive ocean, similar to how the Red Sea was formed. This would reshape the map of Africa, creating new landmasses and coastlines. The impact wouldn't be limited to Africa. It would affect weather patterns, ecosystems, and even global plate movements. While this future is millions of years away, the ongoing rift in East Africa is a fascinating reminder of Earth's dynamic nature. Eastern Africa is undergoing a dramatic transformation driven by plate tectonics. The culprit, the Somali plate, is a piece of crust slowly pulling away from the larger Nubian plate at a rate of a few millimeters per year. This separation creates a vast trench, the East African Rift, extending 2,200 miles from the Red Sea to Mozambique. The future implications are significant. A complete tear could split Africa in two, a geological event not witnessed since the separation of South America and Africa millions of years ago. However, this wouldn't happen in our lifetimes. Estimates suggest it would take 5 to 10 million years. There are several possibilities for how this might unfold. In one scenario, most of Somalia would break away, forming a new sea and a separate continent alongside eastern Ethiopia, Kenya, Tanzania, and Mozambique. Alternatively, only a sliver of eastern Tanzania and Mozambique might separate. This continental shift could have surprising benefits. Landlocked countries like Ethiopia and Uganda could gain coastlines, boosting their economies through increased trade opportunities. As the rift widens, the Red Sea and Gulf of Aden may fill the valley, creating a new ocean. While the rift is visible, its growth is slow. Currently, it widens by only a quarter inch annually, so while the future map of Africa might be dramatically different, it will take time to happen. The East African Rift Valley is a fascinating example of a geological process in action, but how exactly do these rifts form? While the specifics are debated, a popular theory points to heat. The culprit is likely a surge in heat flow from deep within the Earth, creating massive bulges like those seen in central Kenya and Ethiopia. These elevated highlands are essentially the Earth's crust stretching and fracturing under immense pressure. The heat source? Mantle plumes are areas where magma is exceptionally hot compared to its surroundings. This extreme heat melts and thins the overlaying crust, causing the bulges to expand and crack. This process can also trigger widespread volcanic activity on the surface, spewing forth lava flows known as flood basalts. Unlike eruptions from individual volcanoes, flood basalts erupt along cracks in the bulges, blanketing the land like a massive flood. A key feature of rifts like the East African Rift is the Rift Valley itself. These low-lying regions form as tectonic plates pull apart. Unlike river or glacial valleys carved by erosion, rift valleys are the product of plate movement. Interestingly, many rift valleys occur at triple junctions, where three tectonic plates meet at roughly 120-degree angles. In those cases, two plates often split apart, forming a new ocean. The remaining arm of the junction, sometimes called an Aulakogen, may become a rift valley. The Atlantic Ocean itself is a prime example, a result of a triple junction that started in present-day West Africa. Two plates split to form the ocean, while the Aulakogen became the Benue Trough Rift Valley in southern Nigeria. Rift valleys aren't always landlocked. Sometimes they exist underwater, splitting long mountain ranges and forming mid-ocean ridges. These ridges appear as tectonic plates diverge, allowing hot mantle material to rise and solidify, creating a new oceanic crust. The Mid-Atlantic Ridge, for instance, sees the North American and Eurasian plates separating at a rate of about an inch annually, resulting in rift valleys as wide as 9 miles. Similar underwater rift valleys are found in the Pacific Ocean, with the East Pacific Rise marking the separation point between the Pacific Plate and several others. Like many underwater rifts, the East Pacific Rise is riddled with hydrothermal vents, superheated water and fluids spewing out due to geological activity beneath the rift valley. The East African Rift Valley is just one example of a dramatic geological phenomenon. By understanding how rifts form, including the role of heat flow, mantle plumes, and plate tectonics, we gain a deeper appreciation for the dynamic nature of our planet. The Great Rift Valley, stretching from the Middle East to Mozambique, is a geological marvel teeming with volcanoes, hot springs, geysers, and frequent earthquakes. This massive rift system boasts two main branches, the Western Rift and the Gregory Rift. The Western Rift, also known as the Albertine Rift, is a biodiversity hotspot. It features everything from snow-capped mountains and savannas to highland forests and enormous lakes. Dotted along this branch are volcanoes like Mount Nyiragongo in the Democratic Republic of Congo. The Gregory Rift, named after its first cartographer, stretches from the Red Sea to Mount Kilimanjaro. A key feature here is the Afar Triple Junction, where three tectonic plates, the Arabian, Nubian, and Somali, are pulling apart. This widening process is causing the arms of the junction to extend into the Red Sea and the Gulf of Aden. If this continues, the resulting depression could be flooded by the Arabian Sea, potentially turning the Horn of Africa into a continental island. The East African Rift Valley, EARV, is a spectacular gash in the Earth's crust, a living laboratory where we can witness continental plates pulling apart. This 4,000-kilometer-long scar stretches from Ethiopia to Mozambique, boasting two distinct branches, the Eastern Rift Valley and the Western Rift. These branches showcase the diversity of rift features. The Eastern Rift Valley, also known as the Gregory Rift, is a volcanic powerhouse. Here, molten rock bubbles up, forming mountains and spewing lava. In contrast, the Western Rift boasts deeper troughs filled with massive, freshwater lakes. Lake Tanganyika, the world's second deepest, exemplifies the immense scale of these aquatic giants. The ARV's activity isn't just for show, it provides a window into Earth's history. Rift lakes like Lake Superior in North America formed over 1 billion years ago when a failed rift attempt created a depression that later filled with water. These ancient lakes hold stories of our planet's geological evolution. The Dead Sea, on the other hand, tells a different story. This unusual body of water sits in the Jordan Rift Valley, a complex zone where tectonic plates interact in unique ways. Unlike true rift lakes, the Dead Sea occupies a depression that never fully formed. Back in Africa, the EARV is a hotspot for biodiversity. Freshwater giants like Lake Tanganyika teem with life, while shallow soda lakes like Lake Natron shimmer red with salt-loving microbes. Lake Malawi, boasting the most fish species of any lake, further highlights the Rift Valley's ecological richness. The East African Rift Valley, EARV, isn't just a geological marvel, it's a chronicle of our planet's dynamism, a cradle of humanity, and a potential key to a sustainable future. Nicknamed the Cradle of Humanity due to its rich fossil record, the EARV has yielded evidence suggesting the dramatic environmental shifts caused by the rift, think alternating wet and dry periods, may have been the very push our ancestors needed to walk upright and develop larger brains. This 4,000-kilometer-long scar across Africa's face is far from static. The Eastern Rift Valley churns with volcanic activity, while the Western Rift boasts massive freshwater lakes like Lake Tanganyika, the world's second deepest. These aquatic giants, along with ancient lakes like North America's Lake Superior, offer windows into Earth's history. The future of the EARV is a story yet to be written. The immense geothermal potential could provide clean energy for thousands of homes, a beacon of hope in a region facing widespread poverty. However, challenges loom. Rising water levels and potential oil exploration near the lakes threaten the delicate ecological balance. Striking a sustainable path will require careful consideration of these issues. The East African Rift Valley is a powerful reminder that our planet is a constantly evolving story. As Africa slowly splits apart over millennia, the EARV will continue to shape the continent's geology, ecosystems, and potentially its energy landscape. It's a place where the Earth's story unfolds, offering invaluable insights for generations to come. Hit that like and subscribe button for more mysteries.